Overview of Spring Framework. The Spring Framework is an open-source application framework and inversion of control container for the Java platform. It's designed to simplify Java development and promote good software design practices. In this code snippet, we're using the application context, a core interface in Spring for providing configuration information to the application. It's implemented here by class path XML ApplicationContext, which loads context definition from an XML file located in the class path. We define a bean, a Spring-managed object, in the beans.xml file and retrieve it from the context using getBean method. The retrieved object myBean can then be used to invoke its methods, in this case do something. Benefits of using Spring. The Spring Framework offers a comprehensive programming and configuration model for modern Java-based enterprise applications. In this segment, we'll outline some of the key benefits of using Spring. Spring simplifies Java development by providing support for various infrastructure tasks, promoting good design practices, and increasing development speed. It offers inversion of control (IOC) for better decoupling and aspect-oriented programming (AOP) for separating cross-cutting concerns. The framework also enables declarative transaction management, simplifies JDBC operations, and offers excellent integration with other frameworks. With Spring's focus on testability and its lightweight container, applications become simpler to test and deploy, leading to a more efficient development lifecycle. Its proactive community and evolving ecosystem ensure that Spring remains relevant and adaptive to new challenges in application development. Spring Framework versus Spring Boot. Spring Framework provides a comprehensive programming and configuration model for modern Java-based enterprise applications. Spring Boot, on the other hand, is built on the top of the Spring Framework. It simplifies the bootstrapping and development of a new Spring application. Spring Framework offers the foundational building blocks for creating well-structured applications with dependency injection, aspect-oriented programming, and more. However, it requires manual setup of configurations and boilerplate code. Spring Boot enhances Spring Framework by providing auto-configuration options, starters for easy dependency management, and embedded server capabilities, making it much easier and quicker to set up and develop applications, thus removing much of the boilerplate code associated with Spring projects. Core concepts IOC, DI. In the Spring Framework, inversion of control, IOC, and dependency injection, DI, are core concepts that promote loose coupling and ease of testing. IOC refers to inverting the control of object creation and management from the developer to a framework. DI is a form of IOC where dependencies are injected into objects by the framework instead of being hard-coded. In the code snippet, we define a class employee service that requires an employee DAO object to operate. Instead of instantiating an employee DAO inside the employee service class, which would create a hard dependency, we use the auto-wired annotation on the setter method. This tells Spring to inject an instance of employee DAO when employee service is created. Thus, the control of creating and providing the employee DAO instance is inverted from our code to the Spring Framework, which handles it at runtime. Setting up a Spring development environment. To start building applications with the Spring Framework, you need a working development environment. This involves installing Java, an IDE, integrated development environment, and the Spring Framework itself, typically via Spring Boot, which simplifies the setup process. First, ensure Java SDK is installed on your system, as Spring is built on Java. Next, choose an IDE such as Eclipse, IntelliJ IDEA, or Spring Tool Suite, which comes with built-in features for Spring development. Install the IDE and configure it, if necessary, to recognize your Java installation. Finally, use a build tool like Maven or Gradle, which integrates with your IDE to manage dependencies, including the Spring Framework. Both Maven and Gradle leverage pom.xml or build.gradle files to configure project dependencies, respectively. With the build tool integrated, you can bootstrap a new Spring project, often using Spring Initializer, start.spring.io, which generates a project structure with essential configurations. Understanding Spring Framework versions. the Spring framework has evolved significantly since its initial release. It's important to understand the different versions to make informed decisions about which version is appropriate for your project. Major versions often introduce new features and sometimes non-backward compatible changes. Understanding Spring framework versions involves recognizing how the framework has evolved over time. Initially, Spring Framework 1.x provided basic inversion of control (IOC) and dependency injection (DI) features. With Spring 2.x, new functionalities like aspect-oriented programming (AOP) and XML schema-based configuration were introduced. Spring 3.x added further refinement to the core container, introduced annotation-based configuration, and Spring Expression Language (PEL). Spring 4.x was the first to support Java 8 features, WebSocket communication, and had a major focus on removing deprecated packages and defaulting to Java-based configuration. Spring 5.x brought reactive programming support and a baseline for Java 8 and EE7. This version also introduced the WebFlux framework for reactive web applications. Projects are advised to use the latest stable release for the most up-to-date features and security patches. BeanFactory and ApplicationContext. In the Spring framework, BeanFactory and ApplicationContext are interfaces for configuring a Spring IOC container. The BeanFactory provides the configuration framework and basic functionality, while ApplicationContext adds more enterprise-specific features on top of BeanFactory and is generally preferred for modern Spring applications. The given code snippet demonstrates how to initialize application context and retrieve a bean. In this case, ClassPath XML application context is an implementation of application context that reads the configuration from an XML file on the class path. After creating the context, we use it as a BeanFactory. The getBean method is then used to get an object of myBean from the IOC container using its bean ID. Even though BeanFactory can be used, application context is more feature complete and is the preferred way to manage beans. Bean Lifecycle. In Spring Framework, a bean goes through a lifecycle from instantiation to destruction. Understanding the lifecycle is crucial for customizing bean creation and destruction processes by using custom initialization and destruction methods or lifecycle callbacks. Let's delve into the typical stages a Spring Bean goes through. The given code shows a simple Spring Bean class that implements initializing bean and disposable bean interfaces to define custom initialization and destruction behavior. After properties set method is called by the Spring container after setting the bean properties, which is where you can put your custom initialization logic. Similarly, the destroy method is for custom destruction steps and is called before the bean is removed from the container. These methods are part of the broader bean lifecycle managed by Spring, which includes instantiation, populating properties, calling initialization methods, bean usage, and calling destroy methods upon container shutdown. Bean scopes. In the Spring framework, a bean scope determines the lifecycle and visibility of a bean within the application context. Spring supports several different scopes for beans, each serving a specific use case. In the provided code, we define a Spring configuration class called appconfig. Inside the class, we declare a bean method myBean that returns an instance of myBean. The appBean annotation tells the Spring container that a bean should be created, and the as scope singleton annotation specifies that this bean should follow the singleton scope. This means that the Spring container will create and manage a single instance of myBean across the entire container, and all requests for the bean will return the same instance. Dependency injection, constructor, setter, field. Constructor injection in Spring involves injecting dependencies through the constructor of a class. This ensures that the required dependencies are available when the object is created. In the provided code, the class example service is annotated with @component, making it a Spring-managed bean. It has a single constructor that takes an example repository object as a parameter. The @AutoWired annotation is not required on the constructor as of Spring 4.3 if the class has only one constructor. When Spring creates an example service bean, it injects an instance of example repository into the constructor. XML configuration. In Spring Framework, XML configuration is one of the traditional ways to set up the Spring container and describe how the beans are instantiated, configured, and managed. It typically involves writing an XML file with bean definitions. In the provided XML configuration code, we have defined two beans inside the beans element. The mybean bean is an instance of com.example.mybean class, and it has a property called Dependency, which references another bean, myDependency. The myDependency bean is an instance of com.example.myDependency class. The ID attribute is used to uniquely identify the beans within the container. The class attribute signifies the full class name of the bean. The property element is used to set the properties of the bean, and the ref attribute is used to reference another bean. Annotation-Based Configuration. Annotation-based configuration in the Spring framework allows developers to configure the dependency injection using annotations within the Java code, without the need for XML configuration files. The @component, @service, @repository, and @controller annotations are frequently used to mark classes for component scanning, while @autowired can be used to inject dependencies. In the provided code snippet, the @component annotation marks the class myService as a Spring component, indicating that it should be detected during class path scanning. The constructor of myService is marked with the autowired annotation, which means that Spring will inject an instance of myRepository when myService is created. This approach is a form of constructor-based dependency injection. Java-based configuration. Java-based configuration option enables you to write most of your Spring configuration without XML, but with the help of few Java-based annotations on Java classes. It allows for more powerful and type-safe configuration. @configuration, @bean, @component scan, and @property source are amongst the common annotations used to create a Spring application using Java-based configuration. In the provided code, @config is a class annotated with @configuration, indicating that it is a source of bean definitions. The @bean annotation is used to indicate that the mybean method should be called by the Spring container to obtain an instance of mybean. Once defined, this bean can be auto-wired into other components. Externalized property configuration. Externalized property configuration in Spring allows you to externalize your configuration to a properties file, making your application more versatile and environment independent. This way, you can inject property values into your application without hard coding them, and easily change the values for different environments without modifying the code. In this example, application.properties contains properties that define application-specific values like app.name and app.description. The myAppConfig Java class uses the Spring AppValue annotation to inject the property values from the application.properties file. $appName is a placeholder that gets replaced with the actual value of app.name defined in the properties file. Introduction to Spring Boot. Spring Boot is an open-source Java-based framework used to create standalone, production-grade Spring-based applications with minimal effort. It simplifies the bootstrapping and development of a new Spring application by avoiding a lot of the boilerplate code and configuration. It provides a range of out-of-the-box features like embedded servers, metrics, health checks, and externalized configuration, base. The code snippet provides a basic example of a Spring Boot application. The @Spring Boot application annotation is a convenience annotation that adds all of the following: @configuration, @enable auto configuration, and @component scan. It signifies that the class is the entry point for the Spring Boot application. The main method uses Spring application.run to launch the application. When executed, Spring Boot will automatically start an embedded web server, defaulting to Tomcat, and the application will run and be accessible over the network. Spring Boot Starters. Spring Boot Starters are a set of convenient dependency descriptors that you can include in your application. They contain the most common set of dependencies that are required for a specific functionality or feature. For instance, if you want to work with Spring MVC for web applications, you would include the Spring Boot Starter Web Starter, which pulls in all the required dependencies for web development. In the code above, we have specified a Gradle dependency, Spring Boot Starter Web, in the Dependencies block. This tells Gradle to include the Spring Boot Starter for web applications in our project, automatically handling Spring MVC, Tomcat, and related dependencies to set up a web application context. Spring Boot Auto Configuration. Auto configuration is a powerful feature provided by Spring Boot that automatically configures your application based on the libraries present on the class path. This feature attempts to guess what you need and configure it without the need for explicit configuration settings. When you use starters, Spring Boot auto configuration takes place whenever the application starts. In the code snippet, @Spring Boot Application is a convenience annotation that adds @configuration, @enable auto configuration, and @component scan annotations. It triggers auto configuration by enabling it, @enable auto configuration, tells Spring Boot to start adding beans based on class path settings, other beans, and various property settings. Essentially, with this single annotation, Spring Boot will automatically configure your Spring application based on the included jar files in the class path. Creating a Spring Boot application. Spring Boot simplifies the process of setting up and creating a new Spring application. It allows developers to start with minimum configurations without the need for an entire Spring configuration setup. The code snippet defines a basic Spring Boot application. The @Spring Boot Application annotation indicates that this is a Spring Boot application and triggers auto configuration, component scanning, and property support. My application is the main class with a main method that serves as the entry point. Spring application.run, myApplication.class, args, bootstraps the application, starting the Spring application context. Understanding the Spring Boot directory structure. In Spring Boot, the directory structure is conventionally organized to enhance productivity and enforce standardization. Understanding this structure is important for developers to navigate and manage a Spring Boot application effectively. The src/main/java/directory contains the application's Java source files, including the main application class annotated with @Spring Boot Application. Within this directory, packages are structured by feature or layer, e.g. controllers, services, repositories. Additionally, the main resources/directory usually contains application properties, static resources, and templates. The test java and test resources/directories are where the corresponding test cases and resources are placed. By following this directory structure, Spring Boot applications maintain a clean separation of concerns and make it easier for developers to locate specific types of files. Spring Boot configuration properties. In Spring Boot, configuration properties are a way to externalize and manage application configuration. This feature allows for type-safe configuration injection into your Spring components. By defining a POJO, plain old Java object, with fields that correspond to values you want to configure, Spring Boot can automatically bind external properties from files like application.properties or application.yml, environment variables, command line arguments, etc. to these fields. Spring Boot profiles. Spring Boot profiles provide a way to segregate parts of your application's configuration and make it available only in certain environments. It allows you to define sets of properties and beans that are exclusive to a specific environment, like dev, test, or prod. This is particularly useful for managing application settings across different environments without requiring separate builds. This snippet is not complete and does not actually define a profile. A full example would include the profile annotation to specify the active profile a bean should be associated with. For instance, @profile dev on a component would indicate that the annotated bean will only be available in the dev profile. Spring Boot Actuator. Spring Boot Actuator is a sub-project of Spring Boot that adds several production-ready features to your application without having to actually implement these features yourself. It mainly provides monitoring and management capabilities to Spring Boot applications, allowing you to track the performance, health, and various other metrics of your application in real time. The code snippet shown is a Gradle dependency configuration that includes Spring Boot Actuator in your project. By adding this dependency to your build.gradle file, you enable the Actuator features. Once Actuator is on your class path, it will automatically expose a series of endpoints such as /actuator/health and /actuator/info that can be accessed over HTTP to provide information about the application's health, environment, and configuration properties. Spring Boot Developer Tools. Spring Boot Developer Tools is a set of utilities that makes the development process faster by enabling features such as automatic restart, live reload, and configurations for a development-friendly environment. To take advantage of these features, you first need to include the Spring Boot DevTools dependency in your build configuration. The code shown is a snippet from a build.gradle file used in Gradle-based Spring Boot projects. By adding the Spring Boot DevTools dependency, Spring Boot automatically includes and configures the developer tools when the application is running in the development environment. These tools are not packaged for production.